So let's start our first problem. In a gas turbine, air is drawn in at 1.02 bar and 15 degree centigrade and is compressed to 6.12 bar. Calculate the thermal efficiency and work ratio of ideal constant pressure cycle when the maximum cycle temperature is limited to 800 degree centigrade. Take gamma equals to 1.4 and Cp equals to 1.005 kilojoule per kg. So as it is said, it is a gas turbine, so it will works on Brayton cycle, right? So first let me write the given part. First it is given that air is drawn at 1.02 bar and 15 degree centigrade. So T1 equals to 15 degree centigrade equals to 15 plus 273 Kelvin equals to 288 Kelvin. Now P1 1.02 bar. So let me write P1 equals to 1.02 bar. Next it is given after compression the pressure is 6.12 bar. So that is P2 is 6.12 bar, and the next one is the maximum cycle temperature is limited to 800 degree centigrade. That is T3 equals to 800 degree centigrade equals to 800 plus 273 Kelvin equals to 1073 Kelvin. And lastly it is given gamma equals to 1.4 and the value of Cp is given. So gamma equals to 1.4 and Cp equals to 1.005 kilojoule per kg Kelvin. Now for thermal efficiency of Brayton cycle, for thermal efficiency of Brayton cycle, the formula is eta Th equals to 1 minus 1 by Rp whole to the power gamma minus 1 by gamma. Now let me put the value where 1 minus Rp equals to pressure ratio, that is 6.12 by 1.02. The value of gamma is 1.4 minus 1 by 1.4. All these values are already given, that is P1 equals to 1.02, P2 equals to 6.12 and the pressure ratio is 6.12 by 1.02 and the value of gamma is 1.4. So by putting the values in this equation we get it is about 0.403. After calculating you can get this value. So eta Th equals to 40.3%. So this is the first answer. For the second part we need to calculate the work ratio, and that is equal to net work by gross work. So for calculating the net work and the gross work we can use this formula: net work equals to Cp T3 minus T4 minus Cp T2 minus T1 kilojoule per kg. So let it denoted by W. So why Cp? As this process is going under constant pressure. And what is gross work? Let it be W dash, that is equals to Cp into T3 minus T4. So already we know the value of T3 and T1, but we need to calculate the value of T4 and T2 to get these two values. So for this case we know T2 by T1 equal to P2 by P1 whole to the power gamma minus 1 by gamma. So we know that P2 equals to 6.12 and P1 equals to 1.02, and the value of gamma is 1.4 minus 1 by 1.4, and by calculating this you can see that you will get a value of 1.67. Also T3 by T4 equals to T2 by T1, and that we have calculated T2 by T1 1.67. Therefore T2 equals to 1.67 into T1. So 1.67 into 288, that already given value, that is equals to 481 Kelvin. So T2 equals to 481 Kelvin, and now from this relation we can again also get T4 equals to T3 by 1.67, that is equals to 1073 by 1.67, and the value is approximately 643 Kelvin. So now we have all the T1, T2, T3 and T4 values. So now W equals to, so the value of Cp equals to 1.005, it is given. Then this is the network Cp into T3 minus T4. So T3, the value of T3 is 1073, it is given, minus T4 value we have just calculated 643, minus again Cp into T2 minus T1. So 1.005 into 481, that is the value of T2, and the value of T1 is 288. So if you calculate this, you will get the value of W is 238 kilojoule per kg. And now for gross work, that is W dash, the formula is W dash equals to Cp into T3 minus T4, that is 1.005 into 1073 minus 643, and by calculating this you will get the gross work done is 432 kilojoule per kg. So now the work ratio equals to W by W dash, that is net work by gross work, that is 238 by 432, and by calculating this you will get the answer 0.9. 0.55. So this is the second answer.